Hello and welcome to the video. Today we're going to be doing a review and course walkthrough of the Planning and Navigation course for Self-Driving and ROS 2 by Brandi. And if you're just here for the first 30 seconds, is this a good course to take to learn how to do planning and navigation in ROS? I'll go ahead and say the answer is yes. If that was all you wanted to know, you can go buy the course. It's awesome. And you will absolutely be putting in time well spent. But we're going to go ahead here and jump into both what you're going to learn, what the end project is, what his teaching style is, and whether that'll work for you. And it might, depending on how you prefer to learn. And then what you don't see in the course, kind of what to expect there. So let's start off by kind of placing this where it is in the overall course hierarchy. So Brandi has a series of courses around manipulators and self-driving. And each of these courses for those two paths kind of builds on the other courses. So the first course in the self-driving, I believe, is the odometry and control. Then you go to mapping and localization. And then you go to plan and navigation. Now, you can absolutely take those courses in any order. What he ends up doing is he'll provide, if you start, like let's say you start with the course that we're talking about here, planning and navigation. What you're going to have is you're going to have a starter project that already has all of the odometry and control code built out. It's already going to have the mapping and localization code built out. And it'll be, ready for you to go and do planning and navigation. And pros and cons there. The pro obviously is that you can see this is a lot of content. This is, it says 25 hours, 20 hours, 28.5 hours for the one that we're talking about. And that time does not represent how long it will actually take you to take the course. It's 20 hours of video. If you're building everything, you're probably looking at 40, 50 hours of investment for each one of these things, which is expected for something like this. So pros are that it lets you bootstrap anywhere in the process. If you're already comfortable with odometry, if you're already comfortable with mapping and localization, you can jump straight in. And honestly, even if you're not, you can jump in and go ahead and get started, and you're going to learn a lot about planning and navigation. The downsides, and we'll talk a little bit more about where this is going to bite us, is if you run into any problems with the other subsystems, you will not have the knowledge to go and troubleshoot them. And I did run into some of those issues, and I'll talk about it towards the end. So let's move on to what you learn in the course. So there's the, obviously the course intro, some setup information. He is going to walk through an intro to ROS 2. You'll get ROS 2 architecture, some basics on messaging, and then in all of his courses, you're going to find the simple publisher and simple subscriber, just learning some ROS basics there. You're going to get into path and motion planning. And what I like here is that he really builds the entire thing up from scratch. So you are going to code from scratch everything necessary to build the occupancy grids, to build your different search algorithms. You'll build most things in both C++ and Python, which is another pro. If you prefer to mostly work in C++, you can do them all there. If you prefer to mostly work in Python, you can do about 80% of them there. You do run into some stuff later in the course that's only available in C++, just because that's the only thing that the libraries were available for. But for everything where it can be both, you're going to implement these algorithms in both languages. You'll get into some motion planning. You'll get into obstacle avoidance, how to help the robot avoid obstacles. And then navigation and decision making. And decision making are things like, hey, if you found an obstacle, let me back up and try again. So you're really going to build up from scratch most of the algorithms necessary to allow you to plan a path for a robot in a known map. So I want to be specific there. When I say known map, I mean you're launching the robot with a map of the environment that has already been provided. Again, talking about how these courses sort of build over time. Mapping and localization was down here. So planning and navigation doesn't cover SLAM and mapping. It covers how to get from point A to point B. And other robotics courses will frequently just use off-the-shelf algorithms, which sure is probably what you're going to use in real life. And will compress this to a much smaller chunk of information. But what you're learning here is you're getting an in-depth look at the various algorithms that go into, path planning for your robot. But anyway, just starting out there, you will be working with known maps only. The final project, I'm going to go ahead and launch just to show you what you will be able to do when you're finished with this course. Is you're going to have a world here called the Small House World that will launch eventually. This is normal. Gazebo is not the most performant thing in the world. And you're going to have the Bumper Bot, which you'll notice is a virtual reproduction of the little guy that's sitting on my desk here. So your Bumper Bot will have RViz, the visualization suite here, and you'll be able to set a goal in RViz, and the robot will intelligently get there. And we're also going to be able to navigate around. So we set a goal, we're going to set another goal. Now I have messed with this quite a bit, so it might not be as functional as it's supposed to be, but I'm going to go and just drop a box in front of our robot, and it's going to stop because, hey, I detected an obstacle, and you can see down here it says goal failed. But because we have some of those recovery behaviors, we are going to be able to just plan a new goal. It stopped, it failed. We can now send it somewhere else. It's not just running into the box. So it's going to say, hey, I now know about this new obstacle that wasn't on the map, and it's going to start trying to figure out how to get to that new location. And you can see it's a little bit confused, but it'll find its way in a moment. So this is what you're going to build towards the end of the course. Now, the very last, and one last thing. So I've emphasized that you kind of run through all the algorithms by hand. At the end, you do see how to grab the off-the-shelf algorithms and plug them in to actually do navigation. Now, at the very end of the course, you're going to get to the Build the Robot section. And you'll notice that this is pretty short. This is 2 hours and 16 minutes. And what this is, so the rest of the course, he is going to code everything out line by line and talk through all of it. The Build the Robot section is assuming a higher level of expert friendliness. You're gonna get the STL files for these. You're gonna get a hardware list, and you're going to get a series of videos, for the most part, of the instructor assembling the robot from sort of a top-down view silently. So you're not going to get explanations for how everything is supposed to be put together. You are going to get a visual guide where you need to pause and watch very carefully and make sure you wire everything up. This is also not a kit. This is not, something that you're going to be able to just throw together with no pre-setup. And what I mean by that is, in order to build this, so it's about $200 in parts. It's the Raspberry Pi. This little LiDAR sensor up here is about $100 on Amazon. The battery is 30 or 40. Like there's a bunch of components that add up to a couple $100 of just pieces that go into the build. You also need a 3D printer or a friend with a 3D printer. You will need, so I'm not sure how well this will show up on video, but you will need a soldering iron. You'll need to be able to solder in all of those connections on the Arduino. So, right off the bat, you need a couple $100 in parts. You need a 3D printer, a soldering station or soldering iron, a hot glue gun. It is definitely not a zero prep setup. Now, that being said, if you're getting into robotics, a lot of those things are things that you are probably going to end up with anyway. And if this is the project that gets you into sort of building up your workshop, then awesome. That's great. But just want to go into this saying that building the physical robot is both more expert friendly in the sense that you don't get nearly as much information, and it is more difficult from a cost perspective. If you have none of the pieces, if you don't have any parts, you don't have a 3D printer, you don't have a soldering iron, you are probably about $1,000 away from building this little robot, which can be pretty unattainable sometimes. The other thing to talk about is that, the last item here is launch all the functionalities. Because this is focused on planning and navigation, there's no real information on getting the rest of the stack bootstrapped up successfully on the real robot. He'll cover some basics, how to get the stack launched, but it is very, very introductory. If you want to use this in a real environment, you will have to, go back through and figure out how to do mapping. And if you didn't take the mapping and localization course, then you're probably not going to have that knowledge. It's very Googleable. You can probably figure it out. But it's not like once you get through the physical robot setup, you do hit a point where you're going to be, sort of on your own a little bit. And it's not that he won't help. He's very responsive. He answers questions very quickly. But once you've gone from the simulator to the real world, you're at a place where there is a limited amount of help the instructor can be, and there's a limited amount of information required. Or provided, not required. Lots of information required, very little provided. To talk about that, one of the things that I ran into is I couldn't get the basic movement functionality working on the physical robot. It would take off and go for 3 feet instead of going a little ways. Or I would initiate a spin and it would spin 3 times really fast from one tap on the joystick. And what I ended up finding is that I had not hooked up I had not appropriately wired the necessary connections for the Arduino to provide a feedback loop. But I didn't know that and didn't know how to troubleshoot the controller code because, again, that's a completely different course. That was one that I haven't taken because, of course, I jumped straight into mapping and navigation. But because I hadn't gone back through and understood how the actual control system was written, I didn't know how to troubleshoot. I didn't know what was wrong. And I definitely didn't realize that it was because I wasn't reading the motor speeds back in. So I spent several weeks rewriting the control system from scratch, learning Arduino, learning how to make basic, forward, backward functionality work on the robot. And in the course of doing that and realizing all the things that I hadn't thought of, like providing odometry back, I eventually figured out that I was missing some wiring, probably 2 weeks into rebuilding this whole thing. And maybe if I had wired everything up correctly the first time, the instructor's code would have worked. Because I didn't, it didn't. And because I hadn't written it, it was a real challenge to go back and figure that out. Now, our challenge is fine, because when you're taking these kinds of courses, challenges are where you really learn. Which, if I had one critique of this course, it's that there's no, there is a limited amount of challenge available until you get to the very end, unless you take the time to challenge yourself. And here's what I mean. Most courses hit somewhere in between. It's either here's a concept, go code the whole thing, or we're going to code everything out line by line together. And this one leans towards the code everything out line by line together. You're not going to hit points where, or very few points, where he describes a concept and then tells you to, describes how to implement it, maybe gives you some pseudocode, and then you go work on it. If you want those moments, those go struggle for a little while and learn moments, you have to create them. You have to figure out what the concept that we're trying to implement is, and then, go and build it. And since most of the time he's doing code walkthroughs, the concepts are not always as clear as they could be for you to go and implement yourself. And again, that comes down to what you're looking for. If what you're looking for is sort of the code along video style, which I love, I do a lot of those on this channel, then this is great. If what you're looking for is a little bit more of a explain the concepts to me and then let me build a little bit and sort of small mini challenges along the way, then this doesn't quite deliver on that. At the same time, though, I haven't found anything that hits these topics. So this is not a unique thing to his courses. So I guess that's kind of the walkthrough here. You get a lot of really good information. You get good walkthroughs of how to build various navigation algorithms. And when you get to the physical robot, you get a build walkthrough and a good luck. And, it's time for you to go forth in the real world and make it work. And in my experience, that sim to real transfer has been very challenging. I do have it working to the point where I can do basic navigation. And I'm going to go ahead and plug this guy in. And I'm obviously not going to navigate on my desk, but you can see the LiDAR is spinning. And we're just going to do a couple things here just to play with this and show you what this physical robot can do. So I'm going to shell into BumperBot. And I can do all this because it is on the same network as me. Well, I say that, but then it fails. Come on, BumperBot. This is probably waiting for DNS propagation. Not entirely unusual. All right, BumperBot WS, and I'm just going to do a setup.sh. And I don't want real robot launch yet. I want ROS to launch BumperBot firmware v2. And this is actually the firmware I wrote. I never did go back and get the default firmware working. So I'm going to run robotcontroller.launch.py. I did not have a wireless controller. I have a wired controller that attaches to my local computer. So what I did is I actually split up the controller functionality, and ID equals 2, and I'm going to, no, that's actually not what I want. There we go. Joystick. That's the word I was looking for. So I'm just going to launch my joystick here. Over here on the robot, I have launched the controller. And we can see that it did, in fact, die. And I will... Yeah, we got an S2 error. Robot initialized. So let's see. I should be able... Unless it's going to die on me again. Let's see. Yep, we should be in a good spot. And this just kind of shows what I was talking about with things definitely get finicky when we go from the simulated robot to the real robot. Here, let's try this. I am just going to launch the whole thing, realrobot.launch.py. And so that I can use the controller, we will do a use slam true. There's nothing directly tying slam and the controller. It's mostly just that I've got, if I'm using slam, I have the controller wired up. And my controller works. And obviously I can't do a whole bunch of driving because this is sitting on my desk. But you can see the robot is capable of rolling around and moving pretty quickly. It's actually fairly speedy here. And then if I wanted to see what the robot's seeing in my environment, which should be very interesting, because yep, and then you can see what it sees as a slam map, which is not a whole lot, but we can see, like, as I wave my hand, you can actually see the little red blip on the map of it seeing my hand move, which is really cool. Again, it's been kind of complicated to make this work in a real robot, but that's also part of the challenge and part of the learning process. I can say that the course taught me a lot. I can also say that I learned more about physical robots and making a robot work in the real world after I finished the course and tried to actually, launch this guy and make him do some basic navigation around my office. So, no substitute for actually building something and trying to make it work yourself. So yeah, again, going back to the very beginning, if you're looking for something that covers, planning and navigation, this is a great place to start. If you have done nothing with ROS at all, I would strongly recommend going back and starting with this odometry and control course. It is, it's the basics. It's learning how to, do basic robotics control. And it's going to set you up well for these other things. Again, I did half of this and got bored, and it definitely bit me later. But I would try to do these in order if you can. I'd also advise anytime you're buying on Udemy, never to pay full price. These courses go on sale every week, basically. Sign up for a Udemy account, wait a week, and you'll see these things for $14.99 instead of $84.99. Yeah, with that, I'm going to say good luck on your robotics journey, and let me know if there are any other courses that you recommend I take and review. Until next time.